Hi guys, this is Jim Martinez with the 8th grade science, and it's been a crazy month, right? But it's almost over, so I want everybody just to hang in there, right? Last week we covered distichs 8.9 letter A, which is the historical events that lead to the current theory that we have right now. We have a theory that's called plate tectonics, but just going over this from last week, we can see that is it hasn't been called plate tectonics theory all the time. So before it used to be called the theory of continental drift. And this is the guy that started everything. His name is Alfred Wagener, and this is the continent that he proposed that was together at some point. The continent was called Pangaea, right? These are all the evidence. You can see evidence 1, 2, 3, 4, and 5 that Alfred Wagener proposed on his when he published about the continental drift. But of course, if we remember something about that, is that his theory was never accepted by the scientific community because he couldn't explain two things, which is the how were the continents moving and why were the continents moving. So in science, you have to prove those things. Otherwise, your theory is no good, right? So this is what we learned also last week, that the continent that he proposed is called Pangaea. And as you can see, this was a supercontinent. This is about 300 million years ago, so a long time ago, right? And then all this supercontinent spread and then move apart, right? So since he couldn't prove or say why those continents were moving apart, well, that's what we're going to be learning today. Today we're going to be covering uh, the TICS 8.9 letter B, which is plate tectonics. Today we're going to be looking at the theory of plate tectonics. It's not continental drift anymore. And we are going to be looking at this, the formation of the crustal features, right? These are the things that happen due to all this movement of plate tectonics, so how the plates in the planet are moving. So there's a lot of things that you're going to be learning throughout. All right. So just to get started, we are going to be looking at the next ticks that we have there, which is first of all, I want you guys to have this in your composition book. As you can see in this one, this is where you put a Pangaea together and you color it and the whole thing. And remember, this is going to be for a grade, so make sure that you have that. It is on the file that I sent before. So this page was empty. And this is what you're supposed to put on that page, all right? You're supposed to write the ticks, which is this ticks right here, 8.9 letter B. And you're going to relate the theory of plate tectonics to the formation of crustal features. That's what you need to write there. And then these are the items that we're going to cover this week with the theory of plate tectonics. So first, we're going to have to do a little bit of background information. That background information has to be or has to relate it to earth layers, right? Also about convection currents. And this is the focus of the whole thing today, the convection currents. Later on, we're going to see the earth plates, and we're going to see the why and how earth plates move. Um, and we also going to be looking at several evidence. I believe it's like 5 of them that are evidence that actually explain how the plate tectonics theory actually works. The why and the how that Alfred Wagener couldn't explain. All right. So just for starter, let's start looking at what is the main thing. Remember this second one that says convection currents, all right? That's the one we're going to start looking at. All right, so this is what it says on mine. I have here convection currents, and these are currents that happen inside the mantle of the Earth. All right, so we have learned before just slightly about the two main parts of the planet, right? Which is the core and the mantle. And the mantle carries the crust of the Earth, where the plates are actually floating on top of this magma. And then we also have the second part, which is the core, right? We have the inner core and the outer core. So it says here that the currents that we're going to be talking about, the convection currents, happen inside the mantle of the Earth, which is in this area right here that you can see. Okay, and how these currents move, um, and the reason why they're moving is because of the difference in density. Magma has density and also heat. All right, so we're going to be looking at those two. So first of all, we need to know what density is. To understand the convection currents, we need to understand density. So right, let's take a look at what density is. So here I have three different things that we can just explain what density is. As you can see, density of a substance is its mass per unit volume. All right, so that's what the formula will say it is, right? In simple terms, we can say that this is how much matter or how much atoms or how much molecules are found in certain objects, right? Some objects can have a lot of molecules or a lot of atoms inside, or other ones can have a less amount of atoms or molecules, right? So that's going to make a difference in density. Also, objects with atoms that have a higher amount of mass. So we have objects that have the same amount of atoms, but if the type of atoms, let's say lithium over here, as you can see, lithium only has 4 particles inside the nucleus, right? That's what is going to give you the mass. If you remember anything from chemistry back then, this is what you find in the mass. You look at inside the nucleus of the atom and you can see 4 particles. This one atom only has a mass of 4 AMUs. But take a look at gold. This is only one atom. And gold has 79 protons, but it also has 118 neutrons. All right. So if you add them up, that will be like 100 and what 80, I know 197. Yeah, 197 AMUs, and it's only um, one atom, right? So of course this one is going to have a lot more mass. This is an atom of gold, which is a lot heavier. It will have a lot more density than one atom of lithium, which it only has 4. We do have a formula for this, and the formula for um, density is equals to mass over volume, right? If we can put them in a triangular formula, and because I know you are a little more familiar on how to use a triangular formula, this is how it will look like, right? You will have the mass on the top, and then you have the density on the left side and the volume on the right. So you can do all the math operations that you need to do to figure out things about it. All right, so this will be the formula for density if in case you need to find the density of an object, but we don't have to right now, okay? So for today, this is what we want to cover. Look at these two objects. Both of them have the same measurements. They measure the same thing, all right? So we can say that this will be 1 square inch or actually 1 cubic inch, right? And this one too. But look at the amount of atoms that this one has compared to this one. All right, this one has more atoms, or we can say molecules too. Since this one has a lot more molecules than this one, this object has more density. It will be heavier. All right, this is very important for you to understand because the whole lesson is going to depend on you understanding what density is. If we put these two in this perspective, we would say on the density scale, you can see that this one will be a lot heavier. So it will be sinking or it will be moving downwards or it will be falling a lot faster than this one, right? Why? Because this one has more, I'd say more molecules in the same amount of space. And this one has less molecules on the same amount of space as this one, okay? If we look at this picture right here, this picture is also perfect on showing how density works. We can see that all three objects measure the same, right? But notice that this one floats. Only a small amount of the object stays on the bottom. And this one, it also floats, but as you can see, most of the object is underneath the water level. Not this one, as you can see, most of it is outside of the water level. But look at this object over here. This third one has a lot more density, right? It's denser, which means that you put them in water, it's going to completely sink. It's going to go down. It's not going to float. Those two float, yes, but this one is denser than that one because this one you can see that is actually sinking a little bit more than this one, right? So that's basically what the whole thing about this lesson is going to be about for you to understand density, so that way we can um, understand how those convection currents, which are these ones right here, are going to work. And you can see all these arrows and all this stuff in there, and they all have a meaning, and we're going to be discussing this on another video. All right, for right now, this is everything we have. This is G. Martinez. Bye bye.